Hello, everyone. Welcome to the week 8 of Big Data and Business Analytics. Now, this lecture will cover the WEKA classification tool. Now, before jumping to that, two things we need to understand. One is the classification problem, and another is the regression problem. So, if we look at a data in which the decision is a fixed kind of pattern. For example, I'm just trying to open a file in WEKA. Just opening the Explorer. Okay, so now I'm actually sharing the screen. Okay, so in the WEKA, I just click the open file, and I can try to find out the program files. C drive. The WEKA data and say diabetes. Okay, so if we look at the data, include the edit to find all the data, right? So we can see that there are 768 entries of diabetic patient. Now, if we look at the class, so this is actually indicating, tested positive or tested negative. So diabetes is positive or diabetes is negative, depending on these parameters, right? And these are the different patients. So, of course, the end result is, in this particular case, is either positive or negative. So we can see that there are two different classes of results. Therefore, we need to find a formula in which we can identify that based on which criteria we can find a diabetic patient tested positive or tested negative, right? Therefore, when we know that the end result is a fixed class, so in this particular example, there are two classes, right? So if we look at, these are the attributes. So if you look at the class, there are two types of class, which means that there are two classes or two end results. Therefore, it is a classification problem, right? Okay. Now, if we look at another example, for example, say iris data set. Again, if you look at the class, there are three types of classes, right? And if we look at the data, then we can see that these are the different, there are three types of flowers, three species of flowers. One is iris setosa, based on this particular length of sepal and petal, and the other types are possible. Therefore, we need to find a way in which we need to identify that what type of classes we are dealing with. Therefore, in order to find those classes, we can say that this is a classification problem. Good. Okay. Now, I would like to show another thing. So this is the classification problem. So some of the other examples of the classifications problems are, say, spam detection. Suppose we have a big data set in which based on email pattern, the message, sender information, these are the different attributes. And the end result is it is a spam or it is not a spam, right? So therefore, if we try to find a way that based on which attribute it is a spam or not a spam, it is a classification problem. Image recognition. Suppose it is a cat type or dog or horse, what type of animal we're dealing with. Disease diagnosis like healthy or pre-diabetic, diabetic, for example. So most of the examples in WEKA, if you look at the database, you'll find that they are the classification problem. Okay, good. Now, I want to show you another example of what is regression. This is the second type of problem, regression. So there is an example given in GitHub, housing.arff. I just copy that, and then I would like to open that in uh, Chrome. So, and then I'll share that thing. Okay, so I'm sharing that screen. And then if we look at the data set here, uh, of course, in the PowerPoint slide, this data set is given, right? So this is the housing.arff file. And if we want to look at the data, we can see that this is the, in this particular column, make it bigger. And then we see that based on all these attributes of CRIM, ZN, Indus, or whatever, the final result is the price of the house, right? So based on different attributes of the houses, what is the price of the house? So the price of the house is not a fixed type of class because it can be any value. Therefore, when you try to predict not a fixed type of classes, but we try to predict a number, that is called regression analysis, right? Okay, so I think this example is now clear. Now I'm going back to the PowerPoint. So what we can see that um, like predicting the house price based on area, location, or features, forecasting stock prices over time, estimating a person's age based on attributes. Therefore, all these are numeric value. So when you try to predict a value, it is a regression problem. So what is the rule of thumb? If the target variable is categorical, it is likely a classification problem. And if the target variable is numerical and continuous value, it is likely a regression analysis. So there are some examples given for classification or regression. So this is a kind of experiment that if you can look at an example, and if you really follow the quick rule of thumb, then you can uh, tell that, okay, what type of problem we are dealing with. Now, in this lecture, we'll focus on the classification problem. Okay, the first thing is that I shared the WEKA Explorer tool, and uh, um, yeah. So I open, first of all, I open. So this is one of the file. Now, if you look at the thing, is that depending on for different patient, this is the kind of health grade, right? Health grade. So there are two types, 1 and 0. Therefore, we can say that this is a classification problem. Okay. Now, I'd just like to refer to one of the things is that um, this example is actually the health grade of a patient, right? Health grade of a patient. So higher HRV, right? So this is the domain knowledge for any classification problem or AI analysis. We need to have the domain knowledge first. So HRV, if it is higher, it is better, right? And so which means that the opposite and HR is actually, if it is higher, It's an indirect relationship to health grade, which is lower is better. Okay. Now, for example, I'm just trying to explain the thing here. Um, so the first thing is that I can go to the classify and um, I can go to choose and then functions, then logistic, and then I can use all the training set. If I click it, I can get a classification problem in which we can see that 100% data is accurate, right? We can see that is the 100% accurate data, right? So, and also this is the confusion matrix is also important, which means that in the confusion matrix, this is the true positive and true negative. So if someone is supposed to be in a particular group, particular grade, our algorithm predicted it correctly. So all the 44 instances are predicted correctly, and all the 36 negative instances are predicted correctly, right? So therefore, in this matrix, if the column has all the values, which means this is 100% accurate. And we can see that 0 is the other values, right? And this is proven by this particular accuracy of 100%, right? Therefore, this algorithm is 100% accurate. Okay, there are other methods in this particular regard as well. So um, let's see one of the things I would like to probably use another kind of algorithm, say trees J48, right? And then I just use a percentage 6% and then start, right? Then also we can see it's 100% accurate. So this data set is really pretty much accurately identified by all the algorithms, right? And um, if we look at the visualized tree, then you can see that depending on HRV, we can actually decide if it is a 0 class or 1 class, right? Based on only HRV, we can really define that. So this is a really a good example, and we can compare these two algorithms. So the first one was logistic algorithm was applied, and this is the result, and this is the second algorithm. So in WEKA, actually, you can use multiple algorithms to cross-check that which algorithm is giving the highest accuracy. In that case, you can pick up that. Now, in this particular case, we can see that both of them are 100% accurate, but in other situations, it may not happen. Okay. So let's see with other algorithms. So for example, if I go to pre-process, I can open the file. I can go to the C drive. I can open the file and then wake up data, and then probably I can pick the um, diabetes data set, right? Okay, so now we can see here is that um, so these are the algorithm and there are two classes, right? So what I can do in the cluster, first I choose the J40 decision tree, and then I can use cross validation 10 folds, for example, right? And I click it, then I can get this. Now, if you look at this particular data set example, then you can see that uh, this confusion matrix 407, right? And 160. This column is, I mean, this is a true positive and it's a true negative. So every data we should expect in this column. If every data in this column and the remaining data is zero, then the whole process is 100% accurate. But since other values are there, which means that the accuracy is very low, right? 73%, you can see here, 73%. Now, if we change it, like if I use the, um, say, percentage split, and if I make it, say, 90%, right? And then I start it, and then I can see that the accuracy slightly improved, 75%, right? Now I use the train set of all the data, and then I start it. Now I can see that it is improved, right? 84%. So what it proves is that when you use all the training set, then your accuracy improves, right? But for cross validation, personal split, of course, it will slow down. And it makes sense because in training set, if you use all the training set, your training should be the best, right? But then you can ask me then why do I need other things, other techniques? The answer is that in real life the data can be billions of data, so you really cannot use all the training data, right? You need to use split, either cross validation or percentage split. In cross validation, it actually, suppose in the whole data set 100%, you just pick a portion of data uh, as a training set, make your model out of the training set and use that into the other data to check how accurate the model is. Then you can pick another set of training set. So it's a kind of randomly selected different portion and doing the training set and find the average of out of it, right? This is what is happening in percentage split and the cross validation. In case of percentage split, what is saying that 90% of the data is used as the training set, something like that, right? So anyway, we can see that use training set of the accuracy greatly improved, right? Now I can choose another algorithm, say a neural network, right? I use a multi-layer perception, the neural network, and then I run it, right? And then I can see that it is not that good, right? 80%. So 80%, right? Now let's see another algorithm. Let's say Bayes and naive Bayes. And if I do the naive Bayes, it is 76%. Okay. So we actually ran three different algorithms, Bayes, and then the neural network, and then the decision tree, J48 algorithm, right? So J48 seems the best, right? So these three algorithms, for example, here you can see that J48 is 84% accurate, neural network is 80% accurate, and naive Bayes is 76% accurate. So, and I use the whole data set, use training set for all the three algorithms. So for this particular algorithm, I can conclude that for this particular case, decision tree is the best, right? Decision tree is the best. And if I want to draw it, I can see that this is the model. This is the so-called the best model, right? So I think so. This is actually the model, right? So and that is 84% accurate, right? So this is the in your report, in your final report, in classification problem, you basically need to run that problem into using multiple algorithms the way I did it, and then you have to take all the screenshot. So I'm again showing you all the results here. So in the Explorer, for example, J48, this is the result. So you take the screenshot of this page and highlight this 84%. And this is a multi-layer perception neural network. You take the screenshot of these and highlight 80%. And you take the screenshot of naive Bayes network, and then take the screenshot and highlight 76%. So you can conclude that the J48 is the best model for the classification problem in this particular diabetes problem, right? And that is basically you have to show in your report, right? I hope it helps. So try to use the same practice in WEKA, and any question, email me, right? I'll be happy to respond in email if you have any question. Again, thanks for watching that classification problem. So these examples and the PowerPoint slides are given in week 8. So, right. So feel free to run and try to understand by reading that material. Okay. Good luck, all of you. And hope to see you in the next class in Zoom, right? Thank you very much.